With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So the students, in this question we have to find the abscissa of the point on the curve ay square is equal to x cube. Okay, and the condition given to us that normal at this point is having equal intercept on the coordinate axis. Okay, so let's understand the scenario of the question. Okay, so let's say this is my coordinate axis. Okay, so see, the normal will look something like this. Let me draw the normal. So normal is something like this, which is having equal intercept on C. These two intercept is equal. Okay, so this point will be what? 0 comma C, and this point will be C comma 0. Okay, friend, and this is normal to this curve. Okay, what is this? Is normal to this curve. Okay, so tangent will be look like something like this. Okay, wait a minute. See, tangent is always perpendicular to the normal, so my tangent will look something like this. Okay, which is perpendicular. Okay, and my curve will look something like this. Okay, I am doing a rough sketch. Okay, so this will be my curve. Okay, so at this point we have drawn a tangent, and so that this will be my normal, which is making equal intercept on this x and y axis. Okay, so see, the slope of my normal, which is nn here. Okay, slope of nn will be equal to what? Will be equal to c. I can write as y2 minus y1 upon x2 minus x1. Okay, so this will give me c minus 0 upon 0 minus c. Okay, so this will give me minus 1. So the slope of my normal, which is having equal intercept, will be minus 1. So the slope of this tangent, say tt, will be what? See, as these two lines are perpendicular to each other and their product should be minus 1. Okay, see, when two lines are perpendicular, then their slope is equal to minus 1. Okay, so see, slope of this normal is coming to be minus 1. So it means my slope of this tangent is what? 1. Okay, so it means at this point, okay, the slope of the tangent drawn at this point, okay, will be what? Will be equal to 1. Okay, so slope of the tangent is m1 is 1. Okay, m2 is coming to be minus 1. Okay, so by this condition we can find this point now. Okay, so see, for that I can use my curve equation. Okay, okay, so see, by this curve equation I can write, see, this is ay square is equal to x cube. To find the slope of this tangent through this curve, I have to first derivate this. So this will give me 2ay dy to be equal to 3x square dx. Okay, so the derivative, at any point will be dy by dx will be equal to what? Will be equal to 3x square upon 2ay. Okay, student, this will be my derivative at any point. Okay, but we have to calculate this at this point where we having this tangent as this. Okay, which is having a slope equal to 1. Okay, so mean my dy dx should be equal to 1. Okay, this should be equal to 1 at this point, say x1 y1. Okay, so see, as this point is satisfying this curve, as this point is on this curve, so the coordinate will be, let's say my x1 y1 will be something like what? x1. So my y1 will be, so see, from this equation I can write my y1 to be, see, this I can write as that y square will be equal to x cube by a. So my y1 will be equal to something like x1 cube upon this a to the power 1 by 2. Okay, from my curve equation. So this coordinate will look something like this. Okay, so if I put this in this expression, okay, through the derivative, okay, and this slope is equal to 1. Okay, student, so 1. Now I can substitute this point here. So this will give me 3x1 square upon 2ay. In place of y I can put this. Okay, x1 upon a to the power x1 cube to the power 1 upon a to the power 1 by 2. Okay, and this is equal to 1. Okay, as the slope is having its slope as 1. Okay, so I can write this as 2a, wait a minute, into this x1 cube upon a to the power 1 by 2 will be equal to 3x1 square. I have just cross multiplied these terms. Okay, so see, this will give, let me square both the sides. Okay, so that I can remove this 1 by 2. Okay, so on squaring, this will give me 4a square, and this will give me x1 cube upon a, and this will give me what, 9x1 square, sorry, x1 4, as I have done the squaring on the both sides. Okay, so from here I can find my x1. Okay, see, this a cancel this power. Okay, and if it goes there, so this will give me 4a by 9 is equal to x1 4 upon x1 cube will give me x1. Okay, so see, my abscissa coming to be what, 4a by 9. Okay, so this will be my answer for this question. Okay, let me check my options now. So option 2 will be correct. Okay, student. Okay, so this is the solution. Okay, we have given that this normal is having equal intercept, so we can say that this slope is -1, and also we can say that the slope of this tangent is 1. Okay, we can also find the slope through this curve. Okay, by differentiating this curve equation. Okay, so by that we have found the dy by dx expression as 3x square upon 2ay. Okay, and we have equated this to 1. Okay, as the slope at this point is 1. Okay, through which we have find our point of abscissa. Okay, so hope you understand the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.